Hi, my name is Anoushk, and I'm a external contributor to Tinydancer. I'm also an engineer at Paladin, and I also run Tinydancer, which is the validator on Solana. So I'm going to be talking about how scheduling works today on Tinydancer and what we're doing to improve it. So, like scheduling is a very complicated problem, and the reason it's complex and hard is there's like many different variables that we need to optimize for. So, obviously, the first thing you try to optimize for is like revenue, right? You want to extract as much revenue for validators as possible because that's how they run their business. But you also want to make sure that you are not slowing down consensus. You don't want to pack too slow, but then you also can't pack too fast because that affects revenue inversely. You also want to maintain the local fee market structure. You cannot just toss that out. And you want to make sure that the ordering mechanism cannot be manipulated and broken. Like for example, bundles should follow strict ordering, and transactions should not be able to insert between bundles. So all of that makes optimizing scheduling in a generalized way very difficult because if you want to add a scheduler for one validator, it's very easy because you know your priorities. But if you want to ship something that is used by the whole cluster, that's difficult. But at for Paladin and for Tinydancer, we are focusing on one thing, which is increasing revenue without hurting the network in any way, and that revenue should be sustainable. So before diving into what we're doing, I just want to quickly go over the Tinydancer architecture of how scheduling works. So you have one tile, which is like one process that handles packing single threaded, and then there's multiple bank tiles, which is how the transactions get executed, and the pack tile keeps track of which transactions and which accounts are being used in which bank tiles, and accordingly, as it's scheduled, it just sends those transactions to those bank tiles. For normal transactions, it limits how many bank tiles can be used. But for bundles, that limitation is not there. It just sends it to whichever one is available. So you can split scheduling into two sections. One is how often do we want to schedule, and two is which transactions do we pick. So coming to the problem, how often you want to schedule, currently the revenue scheduler, because it uses the block engine for bundles, auction already happens at the block engine end, which is I think a 15-second auction. So on the leader, all it's doing is just calculating what is the optimal time I need to wait given a set of transactions that's already arrived. So as you can see on the left side, it's like very high, but as more transactions come in, the wait time goes lower. And you can see like most of the block, like the 87% of the block is just bundles, and only like 15 seconds is transactions. So that's a problem because that means that no one's going to use normal transactions, and bundles add latency. So this is how bundles are sorted in Tinydancer. There's no concept of a bundle; it's always a list of transactions, and we use the constant to like bucket the ratio of the revenue and the CU to decide to separate bundles. And this is a synthetic fee mechanism that we don't want to rely on. So what can we improve? If we want to like reduce the incentive for using bundles because they add latency, so you should only use them if you absolutely need that kind of atomicity. FCFS, like bundles are FCFS, so it's not like predictable because you want cancel orders to be very predictable. You want cancel orders to always land at the top of the log, and that can be done with if they are ordered rev by CU. And you want very strong incentive for people to pay high priority fees on transactions. But if bundles are automatically prioritized, that's not happening. So in Paladin, what we are doing is first we are only adding a fixed 15-millisecond wait time. That's how often we schedule. That makes it very predictable. The slot is fair, so bundles and transactions are all scheduled together, and they're scheduled like universally. no matter which type of transaction, they all get sorted rev by CU. And this creates like an incentive where you are incentivized to send the lowest CU transactions with the highest priority fees or tips. And because now there's no synthetic fee mechanism used to universally sort them, no one can create like a malicious transaction with a fee such that it lands between a bundle. If we had universally sorted them using the synthetic fee mechanism, we would be open, like we would have had a attack vector for that kind of an attack. So this is how it looks when we have implemented our scheduler, where the whole block is equally split, and universal sorting kind of just combines it into one tree, which is the queue used in Tinydancer, and normal transactions and bundles go sorted together. But one thing about bundles that is really, really good is drop on revert, right? Sometimes you want the transaction to drop if it reverts. And that's a very key feature that I think a lot of searchers using bundles want, but you don't actually need bundles for that. So that's why we added MEV transaction. So what MEV transaction does is basically says like let's allow people to directly send transactions which has the lowest latency, and it's really simple, but they don't need to send a bundle, and they can still drop it, and in case it reverts, right? So you send a trade that your trade is negative, it will just drop it, but it's just still a single transaction. So there's no external auction or block engine that you need to rely on, and you still get the benefit of the universal sorting that we just talked about previously, where it's rev by CU. But there's also one more problem here. Like if you're sending single transactions without a block engine directly to CPU, which can be reverted on, which can be dropped on reverting, there's no like cost to the user if the transaction fails. So this is where like Paladin rate limiting comes up, where we use SPOS and the existing quick interface in the sender client to just like rate limit it. So based on how much PAL you have staked, we calculate how many transactions you send per second, and you don't need to do anything else to use this. You can use the existing Solana client, which uses quick anyway, and just have PAL stake on that address, and you would get rate limited if you send too many transactions above your limit. So this way, like leaders are protected, but they still have higher revenue, and users also get like lower latency and don't have to rely on bundles or an external block engine. And so right now I'm working on we have all of this running in testing on a testnet cluster with Tinydancer, but our team has already worked on this stuff with Agave, and you can see that Agave with Paladin is already doing just as good as Agave with Jito, if not better. And that's just with rate limiting. That's not with any universal sorting. We're adding universal sorting right now. So once that's done, we should see higher revenue with Agave Paladin and Tinydancer Paladin.